new world. The Red Planet has a story, and it begins now.
Mars Saga, episode, Hidden Water Beneath the Red Planet. Mars Saga presents the next episode in our continuing journey across the Red Planet. In this chapter, the focus moves beneath the surface, into a world that cannot be seen from orbit, but shapes everything above it. This episode explores the hidden water of Mars, where ice, minerals, and ancient geology preserve evidence of a planet that once moved, flowed, and changed from the inside out. Mars today appears dry and silent, yet strong scientific evidence shows that water still exists below its surface. This water is not found as open rivers or lakes, but as frozen ice, salty deposits, and possibly liquid brines trapped deep underground. These hidden reservoirs are among the most important discoveries in modern Mars research because they connect the planet's past, present, and future. Early Mars had conditions that allowed water to remain liquid on the surface. Over time, as the atmosphere thinned and temperatures dropped, surface water became unstable. Instead of disappearing completely, much of it moved underground or froze into the soil. This process slowly reshaped the planet's hydrological system, locking water away beneath layers of rock and dust. Radar instruments orbiting Mars have played a key role in detecting subsurface ice. These instruments send radio waves toward the surface and measure how the signals bounce back. Ice reflects radar differently than solid rock, allowing scientists to map buried ice deposits across vast regions. These findings reveal thick ice layers just below the surface, especially in the mid-latitudes. Some of these ice deposits are only a few meters beneath the ground, protected by a thin layer of dust and rock. This covering acts as insulation, preserving the ice for millions of years. In some areas, the ice appears in shapes similar to glaciers on Earth, suggesting slow movement in the past under different climate conditions. At the poles, massive ice caps dominate the landscape. These caps contain both water ice and carbon dioxide. Layer upon layer has built up over time, recording changes in Mars's climate. Each layer reflects a different era, shaped by shifts in temperature, atmospheric pressure, and dust levels. Beyond ice, scientists have also found strong evidence of ancient groundwater systems. Certain minerals, such as clays and hydrated salts, form only in the presence of water. Their distribution across Mars suggests that groundwater once flowed through cracks and pores in the rock, altering the chemistry of entire regions. These underground water systems may have lasted far longer than surface rivers. Even as surface conditions became harsh, water beneath the ground could remain stable, shielded from radiation and extreme temperature swings. This makes subsurface environments some of the most promising locations for past habitability. Deep beneath the surface, pressure and heat may have allowed liquid water to persist even after Mars became cold. Salts lower the freezing point of water, making briny solutions possible at temperatures well below zero. These brines could exist today, slowly moving through rock layers during certain seasons. The discovery of recurring slope features, dark streaks that appear and fade on steep slopes, has added to this picture. While their exact cause is still debated, some scientists believe they may be linked to salty water briefly flowing on the surface before evaporating or freezing again. If true, this would indicate that Mars is not entirely dry even now. Subsurface water has also played a major role in shaping Mars's geology. As water moved through rock, it weakened structures, created voids, and contributed to collapse features such as pits and troughs. Some of Mars's chaotic terrains may have formed when underground ice melted and the surface collapsed above it. Large outflow channels provide further clues. These massive channels appear to have been carved rapidly, likely by sudden releases of groundwater. Such events would have unleashed enormous volumes of water in a short time, reshaping landscapes on a planetary scale. Volcanic regions add another layer to the story. Heat from magma could have melted nearby ice, creating hydrothermal systems underground. These environments are important because on Earth, similar systems support rich microbial life. They combine water, heat, and chemical energy, all essential ingredients for life.
Even after volcanic activity declined, the legacy of these systems remained locked in the rocks. Mineral veins, altered textures, and chemical signatures preserve evidence of past water-rock interactions. Rovers studying these features provide insight into the timing and duration of underground water activity. For future exploration, subsurface water is a key resource. Water can be used for drinking, oxygen production, and fuel generation. Accessing ice beneath the surface could make long-term human presence on Mars possible. Understanding where this water is located and how stable it is remains a top priority. Subsurface water also affects radiation exposure. Ice and soil can provide natural shielding, reducing the radiation that reaches underground spaces. This makes buried habitats more practical than surface structures, especially during long missions. Mars's hidden water tells a story of survival. As surface conditions became hostile, water retreated into safer environments below ground. This transition reshaped the planet's potential for life and preserved chemical records that scientists continue to study today. The search for life on Mars increasingly focuses on these underground environments. If life ever developed on Mars, it may have adapted to subsurface conditions as the climate worsened. Even if life no longer exists, chemical traces could remain preserved in protected layers. Future missions aim to drill deeper than ever before. By accessing samples from beneath the surface, scientists hope to answer some of the most important questions about Mars's history. These samples could reveal how long water lasted, how it interacted with rock, and whether conditions ever supported biology. Mars continues to challenge assumptions. What once appeared as a dry, lifeless world now reveals complexity beneath its surface. Ice, minerals, and geological structures combine to tell a story of transformation rather than disappearance. The Red Planet's underground world remains largely unexplored. Every new discovery adds detail to a picture that is still forming. Mars is not defined only by what is visible, but by what lies hidden beneath layers of time. Mars Saga will continue to uncover these hidden chapters, exploring the forces that shaped the planet and the evidence preserved below its surface. Each episode brings us closer to understanding Mars as a dynamic world with a deep and complex history. Thanks for watching.